just check that the tracker beam is vertical, and we'll use an oil bath reflection to do that. So firstly we need to install the tracker oil reflect disc with a little hole in it, and it's sort of opaque to light on the other side. So we'll clamber up the tower and try not to bump anything, particularly this little wee pick-off mirror. We'll just wedge that in there, not too tightly, otherwise we'll bump the actual tracker itself. Okay, so in theory we have a little beam of light there. Now at the moment it's cloudy-ish out there, so it's far from perfect. The real oil. And we want to put it in the centre. If it's too far on one side, there's a meniscus effect which shifts the beam. And now if we look straight up at the base of the reflection disc, you can see it's perfectly centred, but very susceptible to vibration. And that's telling me that it's perfectly aligned. Of course, in order to do this, we actually have to have the tracker completely aligned, level, and have been running in a optical feedback mode just prior to doing this, otherwise it would be way off. Just a quick explanation how the optical feedback works for the tracker and the telescope particularly. So we have the main solar beam coming down here. There's a small mirror that picks off a tiny piece of the beam, and you can see how much it obscures. It does obscure a little bit, that's no problem. The beam goes up into half a binocular telescope, and then it's focused on 4 diodes in here, obviously up, down, left and right. You can read the writing there, and the computer algorithm just fine-tuned so that is completely centered. Unfortunately, it's a cloudy day, so we've got fairly low intensity light there. The important things, if we were setting this up, we would adjust this 45 mirror here, but we're never going to touch that now. It's set up for life. This is set up for life. The techs will be just checking the trueness of the alignment by eyeballing this reflection here, and that reference spot comes off this little mirror here, and if they really must, they can adjust this mirror. So this, we'll call it the target pick-off mirror or reference pick-off mirror, and it's got some micro threads in there. It doesn't need adjusting, and it should never need adjusting. And if they really want to get the target right on the aperture of the instrument, which we'll look at shortly, they'll be using a 45-degree mirror down the bottom of the tracker, mounted on the tower. Okay, so this is probably the only adjustments the tech should need to make with the solar tracker. Say today is not a great day, it's actually pretty cloudy. I'll take the aluminium cover off on the mirror without bumping it, and looking at the wall, the tracker should have shown that the spot is on target. And looking at the instrument, it's obviously illuminating the front mirror there, the front window. And then, if my colleague is really careful, Director Geddes should be able to image the spot, and you see that the sun is centered completely perfect on the aperture. On the screen you'll see that the diodes values are fairly similar, particularly in pairs, and it displays locked. it's so cloudy today that those values are probably half what we'd expect. I'd be expecting to see at least 150 on here. The tracker is in the enable feedback mode, and so it's enabling some fine tuning, which is a bit drastic at the moment, again because it's cloudy. So you wouldn't attempt to adjust that 45-degree mirror unless it had said locked and for quite a period.